Hello and welcome to my YouTube channel. This is part 3 of Kubernetes crash course for .NET developers. So in the previous two video, in the first video we discussed about the Kubernetes architectures, like we discussed about the master node, worker node and different components of master node and worker nodes. And then we move to pods, and in the previous video we also created a pod for Nginx as well as our .NET Core Web API, and then we try to access our API through browser, but we found that we were unable to access our Web API from the browser. And after that, we tried to access that same API inside the container from with the shell command, and we were able to access it. Then we concluded like we are unable to access our Web API from browser. So today, that was the problem statement we discussed in the previous video, and today we are going to resolve this, and we will see the how can we resolve and expose our API publicly. So today we are going to discuss about the service, and if you will see here, there are basically three types we can say for service, like cluster IB, node port, and load balancer. There are a few more service types, but basically today we are going to discuss about this three service type. So uh, as we know that pod can live and die, right? So last video we created our web API project with the pod name Hello Kubernetes. And it is, for example, if it is running with the three pods, we change the replica to three, then we are having a three pods. And if you observe, each pod is having a different IP address, 21, 22, and 23. And due to some reason, if any one of pod is going to die, suppose this 22 pod is not available, it's terminated. So we know that in the Kubernetes deployment, we are having a self-healing mechanism. So when Kubernetes will observe like one of the pod is getting died, it will replace that pod with the new pod. So we can see that now the 22 pod is replaced with the new pod, and also we observe when the new pod is getting created, we observe that the IP is changed to 28. Previously it was 22. So if we want to communicate directly to pod, then it will be very challenging, right? Because pod can live and die, and each time whenever the pod is going to create it, new IP is going to assign it. Then we need to you know, adding that IPs in our applications and managing that will be very difficult, right? So to resolve that, we are having a concept in the Kubernetes that's called service. So instead of directly calling our pods, we can communicate with the service, and then service can communicate with the pods, and service will resolve that IP issues. Service will have only one static IP, what we are going to use that, and then service will take care of the that pods creation and die part, right? So this is a one of the benefit of service as well, that we can say that service discovery, because each time pod will be deleted and new pods will be created. Then to find out that, to discover that service, discover that pod, all that thing can be done by the service. We are not going to take care of that. So here we can say that our client is going to communicate through service. Now let's discuss about the three types. One is a cluster IP. So if service type is cluster IP, then we can access that service inside the cluster only. So if I will try that service from the browser, from the internet, then I will not be able to access it. So that type is cluster IP service. Suppose instead of that I want to provide access for only for my node. Suppose I'm running on worker node 1. So whoever is having access to worker node 1 should be able to access my services. Then I can go for node port. So suppose my worker node is installed on deployed on EC2. So whoever is having access to the EC2 network, that service, that person can access the this service as well. And the third one is load balancer. So suppose if I want to deploy my service publicly and anyone on the internet want to access my service, then my service type should be a load balancer, and then uh, the person who want to access my service can access it. So as we already discussed, also the other one of the benefits of the service is like a load balancing. So we can see that for one application we are having three pods. So service will take care of the balancing load as per the, like we are having three pods. So if multiple traffic is coming, then equally distribute the load to the different pods. That is taken care by service. So now let's see everything in action, and let's see the pod what we created last time. So let's move to the terminal. So let me run kubectl get pods command to list out the previous pods what we created for our .NET applications. So we can see that one pod is running, and let's try to, let me again try to show you if I'm able to access it from browser or not. So let me open this. So it was exposed on 8080 and I'm not able to access it, right? So let me copy this URL and let's get the shell inside the container. So we will run again same command kubectl execute it and then pod name dash dash then slash bin bash. Oh, so I so I copy instead of pod name I copied the URL. So let me fix this. Let me copy the pod name and let's enter. Yeah, so we are inside our container. Now let's try to run it. Let me copy this URL again and paste it here. So here we can see that Swagger page, we are able to access it from the container, but not from outside from the container. Now, as we can see that currently we are having only one pod, but let's change it to three pods. So how can we do that? Correct, yeah. We need to update the replicas. So let's move to our KTest folder. Here we are having our YAML file, right? And let's open this YAML file. I'm using Visual Code here. And here we can see that replicas is 1. Let's change this replica to 3. And now we are going to, what command we are going to run? Yes, kubectl apply command. And here what we will do, we will give the file name. So what is our file name? It's hello kubernetes deployment.yaml. So let's copy and paste it here and let's hit enter. So it's configured. Now let's run kubectl get pods command. So now it is in the container creating a status. Let's wait for some times and then this other two pods should be in the ready states. So let's clear this and now let's run again kubectl get pods, and this time actually I want to see the IP address also. So if you want to see the more information, then you can run this command with output and then you will say like void. So with the wide, it will even display the IP address also for the pods. So let's hit enter. So this time we can see that our three pods are running for our application, and IP is 31, 28, and 32. Now let me try to delete one of the pod and see that self-healing mechanism, right? We discussed like if any pod is going to delete it, then we are having a self-healing mechanism and our deployment will automatically create a pod, but that IP is going to change. So let's see all that thing in the action. So what I'm going to do it, I'm going to delete one of the pod. Maybe I will delete uh, this third one. Okay, then maybe I will delete this third one. So this is having IP address 32, right? So now let's say kubectl delete pod, and then I can give the pod name, and let's hit enter. So we can see that pod deleted. And now let's run get pods command again. So now we can see that we are having a 32. If you will see this 32, and this RQLN7 pod is not available, but Kubernetes replaced that pod with the new one. You can see this 13-second one with the IP address 33 is getting created. So whatever we discussed, like pod can live and die, and new IP address is going to assign. And we also saw like we are not able to see our API in the browser. So, and also we discussed like to resolve that we need to create a service. So let's go to browser, and as we created deployment similar way, let's search for Kubernetes service. So here you can find the service, and from the Kubernetes documentations, if you will scroll down, you can see one YAML configuration for service. So instead of writing your own YAML configuration, you can copy this and modify as per your requirement. So let's copy this and let's paste this here below. Maybe we can create a new file as well, or if you want to continue on the same file, then you need to do one thing. Here you need to add this 3 dash, and after that you can paste your service. So here let's modify this as per our need. So it should be service only here instead of my service. Like we are having this .NET deployment, so I will say maybe .NET service, .NET service. And this is very important. Selectors, you need to be very careful. Whatever you are giving here, like we have defined the labels app.net, same selectors we need to give here as well. So we discuss about the service discovery, right? Because IP will change, but how service will find out the pods with the selectors with the help of labels only. So our labels all we are having with the app.net. So let's add that same label here. Dot, oh no, .net. Now we know we are our container port is 8080, so let's change this to 8080, and even let's change the target port also to 8080. Yeah, that's all. Now let's go back to our terminal and let's clear this, and now let's run kubectl apply command again. So we can see that this deployment we did not make any changes, so it is unchanged, and then we can see that service is created. Now let's run kubectl get pods output equals to white. So it is still same 31, 33, and 28 IP address. Now let's run kubectl get service command. So we can see that our .NET service is created, and by default, when we are, when we are not defining the type of the service, by default, the cluster IP service is going to create it. And as we discussed, cluster IP service, like if I will, even if I will try to access my service outside uh, from the cluster, then still I will not be able to access it. So now we need to change it to make it available publicly. We need to change it to load balancer type, right? So let's go back again, and here I will say type load balancer. Save this, and now let's run this command again. And let's run get service again. So this time we can see that our service is load balancer type. But one more step we need to do, because we are running this inside the minikube, so we need to tell our minikube, right? Like this is a service what we created, and then minikube will generate the public URL for us. So I will say like minikube service, and we can give this name as a .NET service. And let's hit enter. So now we can see that minikube created even the URL for us, and it is opening that in our default browser. So let me try to access this, and let's try to access our Swagger. So great. Now with the load balancer, we are able to access our service as well. And yeah, same response also we are getting. So that's all for this section of the video, and in the next video we are going to run multiple containers in the single pod. So what we are going to do is, if you remember in one of our previous video for Docker, we used Postgres Docker image, and then with the Docker Compose, we were able to then use that for the web API. So same solutions we are going to use it, and both the Postgres container and our API container we will try to keep in the one pod, and we will run it. And there's one challenge we will see when we are going to execute this process, and we will see all the possible solutions for that also in the upcoming sessions. So, and before I end this session, I will highly recommend, if you have not watched this 4 Docker videos, I will highly recommend you to watch these 4 videos first. In the first video, we are just Dockerizing the .NET applications. Second video, we are seeing how can we run with the HTTPS protocol. Third video, we are using the Postgres container, Docker container, and we are having one CRUD applications. And in the last video, we use Docker Compose orchestrator to run our Postgres and other container together. So if you have not watched this video, so please watch. This will be very helpful for you. So let's move to our knowledge check section. So in the knowledge check, you will have one question with the four options. You need to think of the correct options based on the this video and our discussions. And maybe you can stop your video and give your answer in the comment box. So let's start, and you will get approximately 10 seconds for each questions. So let's begin. So our first question is, if you are not specifying type, what is the default service type? And we have these four options: cluster IP, load balancer, node port, and or maybe an error will occur. So you have 10 seconds and your time starts now. Okay, so the correct answer is cluster IP. Now moving to next question. What type of service is used to allow API publicly? So if I want to access my API, my service globally on internet, so what type of service I should use? And again, we are having a four option. Number one is public service, number two is cluster IP, number three is node port, and number four is load balancer. Maybe again you can stop your video and you can provide your answer in the comment box. And you have 10 seconds to answer this, and your time starts now. Okay, time up. So correct answer is load balancer. Now moving to our third and last question. How can we see IP address of pod with kubectl command? So if you remember, we executed some command to see the IP addresses, and then we deleted one of the pod and we found like a new IP is assigned, right? So what command we executed? And we are having four options: kubectl get pods, show labels, kubectl get pods command, kubectl get pods output equals to void, and kubectl get pods IP. And you have 10 seconds to answer this, and your time starts now. So time up. So correct answer is kubectl get pods output equals to void. So that's all for this video. If you like this video, please don't forget to hit the like button. If you have not subscribed my channel yet, please subscribe and please share with your friends. Thank you for watching. Have a great day.